In our lesson today, we're going to be graphing linear equations. Before we do that, though, let's review what we learned before about how to write the equation of a line in slope-intercept form. Okay, state the y-intercept and calculate the slope of each line, and then write the equation of the line in slope-intercept form. So our first graph here, the y-intercept b, the line crosses the y-axis at this point right here, which we can see has coordinates of 0, 2, meaning that b, the y-intercept, will be equal to 2. All right, now to calculate the slope, I need one other point that this line goes through, and it looks like it goes through this point here, which has coordinates of 2, 1. Okay, so to calculate the slope, I can do 1 minus 2 over 2 minus 0. Okay, this would be my y2 minus y1, x2 minus x1. And then that's going to give me a value of negative 1/2 for the slope, meaning the equation of the line, all right, is going to be equal to y equals negative 1/2 x plus 2. In our second picture, okay, we have a y-intercept right here. Now, it's not clearly going through this point, which is at 0, negative 4. It's a little bit below that. So what I did earlier, I calculated what the y-intercept was, and it came up with a value of negative 14 thirds for the y-intercept. All right, let's find 2 points that this line is passing through. So it looks like it's passing through this point right here. And notice if I look at my markings here, I'm not counting by ones, but I'm counting by twos as I go along here. So my x coordinate is going to be a 2, and it's the same thing down and up on the y-axis. They're counting by 2 each time. So if I go down that first line, that's going to be at negative 2. 2, negative 2 is that coordinate. Okay, and if I find a point right here, that would have coordinates of negative 4, negative 10, negative 4, negative 10. So let's calculate the slope. Okay, I can do negative 10 minus negative 2 over negative 4 minus 2. All right, so again, y2 minus y1, x2 minus x1. Negative 10 minus negative 2 is negative 8. Negative 4 minus 2 is negative 6. And negative 8 divided by negative 6 is the same as 4 thirds for the slope. So the equation of the line is going to be y equals 4 thirds x minus 14 thirds. All right. How about for the bottom two pictures? Okay, this time we don't have diagonal lines, but in the first picture we have a horizontal line, and in our second picture we have a vertical line. We learned before that a horizontal line will always have a slope of 0, and we learned that a vertical line will always have a slope that is undefined. Okay, let's deal with the y-intercept of the horizontal line right here. That's at the point 0, comma, negative 1. Okay, so if I write my equation in slope-intercept form, I would be writing y equals 0x minus 1. But 0x is just 0, so really I can just write the equation as y equals negative 1. That is what the equation of this line is. And if you look at any point that's on this line, we've got 0, negative 1. I can go right here. This is 4, negative 1. I can go back this way. This is negative 4, negative 1. Okay, how about that point at negative 2, negative 1? This point right here at 2, excuse me, right here, I should say, at 2, comma, negative 1. All right. If you look at the y coordinates in every point, it's at negative 1. So the y coordinate equals negative 1. Y equals negative 1 is the equation of the line. For the vertical line, the y-intercept, well, this vertical line is never going to intersect with the y-axis because they are parallel to each other. So it doesn't exist. There is no y-intercept. Okay, there's no y-intercept. The slope is undefined, but we can still make an equation. Similar to what I did over here with the horizontal line, I'm just going to pick random points. So there's this point right here, which is at negative 3, 0. There's this point right here, which is at negative 3, 3. There's this point down here, which is at negative 3, negative 3. This point here is at -3, -5. This point up here is at -3, +5. If you look at all of these points, what do they have in common? Well, the first coordinate, the x coordinate, is equal to -3. So the equation of this vertical line is going to be x equals -3. Okay? A vertical line will always have an equation that it says x equals some number. A horizontal line will always have an equation where it says y equals some number. We are now ready to graph lines written in slope-intercept form. In order to help, we will create a table of values based on the equation of the line. In our first example, we're going to graph the line y equals 2x plus 1. Okay, I already have a couple of hints about my line as I look at this equation. I know it's going to have a slope of 2, which is positive, so my line's going to be increasing as I move from left to right. And the y-intercept is a positive 1 here, meaning it's going to cross the y-axis at 0, -1. Okay, here's my equation, and I'm going to create a table of values based on this equation. So I'm going to come up with x values, I'm going to substitute that into my equation, and then I'm going to figure out what the y values are. Okay, for my x values, I always like to start with x equals 0, okay, because it's easy to calculate. Y equals 2 times 0 plus 1, which means y equals 0 plus 1, which means that y equals 1. So my first point is going to be at 0, 1, which I move 1 unit up from the origin right here. And again, that's going to be my y-intercept. Okay, I still have 4 more x's that I'm going to pick. 2 of them I'm going to have be positive numbers, and 2 I'm going to have be negative numbers. So for my positive numbers, let's use 1 and 3. For my negative numbers, let's use -2 and -4 just for fun. Okay, I like negatives and positives that are close to 0 because, again, they have to fit on my graph. Okay, so when x is 1, y equals 2 times 1 plus 1, which becomes 2 plus 1, which equals 3. So my next point is at 1, 3. 1, 3 is right here. All right. And then if x equals 3, y equals 2 times 3 plus 1, which becomes 6 plus 1, which is 7. So 3, 7 is my next point. 1, 2, 3 to the right, up 7 right here. If x is -2, y equals 2 times -2 plus 1, which becomes -4 plus 1, which is -3. So -2, -3. 2 to the left and 3 down right here. And finally, if x is -4, y equals 2 times -4 plus 1, which is -8 plus 1, or -7. -4, -7. So I'm going to go 4 units to the left, 7 units down right here. Okay, and I've got my 5 points that I am now going to connect with a ruler. Okay, so let me pull out a ruler, and I'm just going to connect these 5 points together. Make sure everything's lined up. And I'm going to extend through the points. I'm not going to stop at the points, but I'm going to extend through the points in both directions. There's my line. Now I'm going to put arrows on both ends because this line could go on forever if my paper was large enough. And then the final thing I'm going to do is label the line with its equation. Y equals 2x plus 1. Okay, so I had a y-intercept of +1, which I knew before. My slope is a +2, so as I go from left to right, my line should be increasing, and it is. In our next example, it says to graph the line y equals -1/2 x plus 7. Okay, so let's pick out some x values so that we can figure out the y values that go along with those. And again, I always like to start with x equals 0 because it's easy to calculate. Y equals -1/2 times 0 plus 7, which becomes y equals 0 plus 7, which is just 7. So 0, 7 just goes straight up 7 units from the origin right here. And that again is going to be the y-intercept. Now I'm going to choose my other x values. Now notice I have a fraction this time, -1/2. Since I'm dealing with halves, I'm going to pick even numbers to use for the rest of my values, because if I choose odd numbers, I'm going to end up with a decimal, and I don't want to graph halfway in between some of these points. So let's choose even numbers for x. How about 2 and 4 for the positives, -2 and -4 for the negatives? And let's go ahead and substitute in. X equals 2. Y equals -1/2 times 2 plus 7 becomes, well, -1/2 times 2 is -1 plus 7, which equals 6. So 2 comma 6 is going to be our next point. Write 2 up 6 right here. And then if x equals 4, y equals -1/2 times 4 plus 7. -1/2 times 4 is -2, plus 7 is 5, so 4 comma 5. Write 4 up 5 right here. Okay, if x is -2, y equals -1/2 times -2 plus 7. -1/2 times -2, a negative times a negative is a positive, so this is +1 plus 7, which is 8, -2, 8. Left 2 up 8. And finally, if x is -4, y equals -1/2 times -4 plus 7. -1/2 times -4 is 2, plus 7 is 9. -4 comma 9. So to the left 4, up 9 right here. Okay, so those are my 5 points. And now again, I'm going to use my ruler to connect those. And again, extend through the lines in both directions. Don't just stop at the points. Okay, make sure that I'm hitting all of my points here. And here comes my line. And then again, let's put some arrows on the ends. All right, and then label the line with its equation. Y equals -1/2 x plus 7. All right, the y-intercept right here is at 0, 7, which I knew from the equation. And it was a negative slope. My line is decreasing as I move from left to right, so I know I've got a good line. Example 3 says to graph the line x equals -4. All right, x equals -4. Well, if we recall from earlier in the lesson, we had this example right here where it said x equals -3, and that was a vertical line. Okay, so what I'm going to have here then is another vertical line, and they've told me here that x equals -4. That means all of these x's here can only be -4. Every x value has to be -4. The y values can be whatever we want them to be, all right? So 0, 3, 7, -4, -5, okay? All of these points are going to be along the same vertical line. So -4 is 0, is 4 units to the left of the origin. -4, 3, just go up 3. -4, 7, go up to 7 now. All right, -4, -4, go down 4 here, right there. -4, -5 is just one more point lower. And we can see very clearly now that they're all along the same vertical line. So if we go ahead and graph this now. All right, here we go. And again, extend through all of your points, put some arrows on the end, and then label it with its equation. X equals -4. Okay, when they've told us what the x value has to be, there's no work that has to be done, so we can just easily choose what our values are. Okay, it's going to be very similar for the next example underneath. This time it says that y equals 5. And again, if we recall from earlier in the lesson, we had this example, all right, where it said that y equals -1, and that gave us a horizontal line. So that's exactly what we're going to get again. Y has to equal 5. So all of these y's are going to be 5. And the x's we can choose whatever we want. 0, 1, 6, -3, -7. Okay, no work to be done. Let's just plot our points. 0, 5. All right, 0, 1, 2, 3, 4, 5. Straight up, there we go. 1, 5 is just one more unit over to the right. 6, 5 is going to be right here. Negative 3, 5 is right here. And negative 7, 5 would be right here. And so again, we can clearly see that they're all along the same vertical line. So if we line up our ruler, go ahead and connect those. And again, we can put arrows on the ends. And we can label it with the equation y equals 5. And that's really all there is to it. So when we get these nice special lines, vertical lines and horizontal lines, coming up with the table of values is very easy because they've given you the rule. Y has to be 5. X has to be equal to negative 4. Example number 5, y equals negative 3x. Okay, let's choose our x values. Again, I always like 0. All right, let's use 2 and 3 and negative 1 and negative 4. Those all seem like good values. Okay, so if I go ahead and substitute in now, y equals negative 3 times 0, which is just which is just 0 rather, 0 comma 0. Hey, that's the origin. My line is going to go through the origin, so this is going to be a proportional relationship. X equals 2. Y equals negative 3 times 2, which means it has to equal negative 6. 2 comma negative 6 is down here. All right, x equals 3. Y equals negative 3 times 3 is negative 9. 3 comma negative 9. 1, 2, 3 to the right. Down 9 is right here. X is negative 1. Y equals negative 3 times negative 1, which is going to be positive 3. Negative 1, 1, 2, 3, up. There we go. And x equals 4. Y equals negative 3 times negative 4, which equals 12. I would go 4 units to the left and up 12. Uh-oh, that's actually going to be off of my graph, but that's okay. I still have 4 points that I can graph, that I can connect in order to make my line. So no worries about going off the graph with that last point there. Let's connect with our ruler. Okay, and again, extend through all of your points. And let's go ahead and put some arrows on the ends. And again, label the line with its equation. Y equals negative 3x. Okay, the slope was a negative number, so our line is decreasing. And again, nothing here to add at the end. This was actually already in the form y equals k times x, so I know it's going to be a straight line that goes through the origin. In our example underneath, y equals 4x minus 6. So again, let's go ahead and choose some x values that we can use for our table. 0, 1, 2, negative 1, negative 2. I'll keep it simple this time. All right, if x is 0, y equals 4 times 0 minus 6, which is just 0 minus 6, or negative 6. 0 comma negative 6. So we'll go straight down 6 from the origin right there. All right, x is 1, y equals 4 times 1 minus 6, which is 4 minus 6, or negative 2. 1 comma negative 2 is right here. X is 2. Y equals 4 times 2 minus 6, which is 8 minus 6, or positive 2. 2 comma 2. 1, 2 to the right, up 2 right there. X is negative 1. Y equals 4 times negative 1 minus 6, which is negative 4 minus 6, or negative 10. Negative 1, negative 10 is way down here. And then if x is negative 2, y equals 4 times negative 2 minus 6, which is negative 8 minus 6, or negative 14. Negative 2, negative 14 would be 2 units to the left, 14 units down. So again, that's going to be off of our graph. But again, we have enough points where we can connect them to make our line. So let's go ahead and connect those 4 points that we do have. All right, so again, extend through the line, or through the points rather, in both directions for your line. arrows and give the equation y equals 4x minus 6. The y-intercept is here at 0, -6, so our b value is -6. Slope is +4. My line is increasing as I move from left to right, so I know I've got a good graph. In example 7, they tell us that a line has a slope of -3/4 and passes through the point 4, 4. They want us to graph and write the equation of the line. Okay, well, fortunately, they gave me the slope, so I know my equation is going to start out as y equals -3/4 x. And now I just have to figure out what the y-intercept is going to be to finish this equation. Now they told me the line of the line rather goes through the point 4, 4. So let's plot that point. Here's the origin, 4 units to the right, 4 units up right here. Okay, and now I've got to get other points that are on this graph. Okay, now what I'm going to do, I'm not going to make a table this time, but I'm going to use my slope. If you remember the slope, -3/4. Slope is the rise over the run. The numerator tells you to move vertically. The denominator tells you to move horizontally. If my numerator is -3, that means I'm going to move down 3. And then my horizontal change, my denominator is a +4, so I'm going to move to the right 4. So I'm going to go down 3, right 4, down 3, right 4. And that's how I'm going to get from point to point. So here's my first point that I already know. I'm going to go down 3, 1, 2, 3, and then to the right 4, 1, 2, 3, 4. That means that this is another point that's going to be on my line. I'm going to go down 3, 1, 2, 3, and to the right 4, 1, 2. Uh-oh, I'm off the graph. But that's okay. I can come up with another point, right? If I go back to my original point at 4, 4, I can just do the opposite of what I did here. Instead of going down 3, right 4, I'm going to go up 3, left 4. So from this point, up 3, 1, 2, 3, and to the left 4, 1, 2, 3, 4. And again, up 3, 1, 2, 3, to the left 4, 1, 2, 3, 4. And now I actually have 4 points that I can connect with my ruler. All right, so let's go ahead and do that. Get everything lined up and connect those. Go ahead now and put the arrows on the end. All right, and now I can clearly see that the y-intercept is right here at this point, which is at 0, 7, meaning that the equation of my line is going to be y equals -3/4 x plus 7. So let's go ahead and label that. Y equals -3/4 x plus 7. Okay, always remember that the slope tells you how to move from point to point, the rise over the run. Now, they want to know, does this line pass through the point 20, 9? Well, I only go up to 10 here on my x-axis and not up to 20, so that's not going to show up on this graph. But I can use this equation to figure out if it will pass through this point. Okay, so my x value is 20, so I'm going to replace x with 20 here. And my y value is -9, which I'll put right here. -9 equals -3/4 times 20. I'll put that over 1 plus 7. All right, let's see what happens when I evaluate this. -9 equals, all right, 4 goes into 25 times. So this is -3/1 times 5/1, which is -15. Add 7. Well, -15 plus 7 is -8. -9 equals -8, which is not a true statement, therefore meaning that this line does not go through the point. So no, the line does not go through the point 20, -9. All right, the line will not go through that point because the equation here was not true. In our final two examples, I'm going to use 2 points that the line goes through in order to come up with the equation of the line. In example 8, we're told that a line passes through the points 2, 5 and 5, 17. What is the equation of the line? All right, well, if I'm given 2 points, I know right away I can calculate the slope m. M equals, all right, let's use this as point number 2, and this is point number 1. All right, so to calculate the change in y over the change in x, I'm going to do 17 minus 5 over 5 minus 2. All right, 17 minus 5, 5 minus 2. And if I were to calculate 17 minus 5, that's 12. 5 minus 2 is 3. 12 over 3 equals 4. So the slope m equals 4. That means I know my equation is going to start out as y equals 4x, and then plus b, whatever that y-intercept is. Now, to come up with the value of that y-intercept, all I'm going to do is pick one of these points and substitute in their values and then solve for b. So let's use 2, 5. All right, y is 5. 5 equals 4 times x, which is 2, plus b. All right, to evaluate b, what I'm going to do is 4 times 2, which is 8. 5 equals 8 plus b. And now to get b alone, just subtract 8 from each side. And b equals -3. So my slope is 4. My y-intercept is going to be at 0, -3. So my b value is -3. So my final equation is going to be y equals 4x minus 3. The line that goes through these 2 points has the equation y equals 4x minus 3. Number 9, a line passes through the points -2, 5 and 2, 3. What's the equation of the line? So again, let's do the slope first, change in y over the change in x. Again, I'll use that as my second point. That one's my first point. Change in y, 3 minus 5 over 2 minus -2. 2 minus -2. 3 minus 5 is -2. 2 minus -2 is 2 plus 2, which is 4. -2 over 4 is -1/2. So the slope m is -1/2. Okay? That means my equation is going to start out as y equals -1/2 x plus b, whatever that happens to be. All right, and let's use this point now to figure out what the b value is. Y is 3. 3 equals -1/2 times x, which is 2, plus b. 3 equals -1/2 times 2. The 2 simplify the 1s. -1 over 1 times 1 over 1 is -1 plus b. And now to get the value of b, just add 1 to each side, meaning that 4 equals b. So there's my slope. There's my b value for the y-intercept. Y equals -1/2 x plus 4 is the equation of the line that goes through these 2 points.